Hi, my name is Billur Kazaz, and I'm a PhD student at the Department of Civil and Environmental Engineering. Today in this presentation, I'm going to talk about deep learning-based aerial stormwater inspection. Erosion can be defined as the transport of soil by wind, water, or ice, and sedimentation is the process of deposition of those eroded particles. Construction sites tend to create large amounts of sediment laden due to the nature of ground disturbing activities. And United States Environmental Protection Agency states that construction sites create an annual soil loss up to 100 tons per acre. So therefore, there are rules and regulations that protect water bodies from construction-related sediment discharge, and these are National Pollutant Discharge Elimination System, and through NPDES, there's Construction General Permit. Construction General Permit requires regular inspections of temporary erosion and sediment control practices on construction sites. And these inspection requirements include qualified personnel, frequent inspections, improvements by the permittee, and proper record keeping. When we look at current stormwater inspections, we see that the common methodology includes on-foot inspections, which require inspectors to walk to further distances. They use basic inspection forms, and they take random pictures of practices by using their phones or regular cameras from ground perspective. This methodology creates challenges because it is time-consuming, it requires a lot of resources, and record keeping becomes difficult. Therefore, our research objective is conducting aerial inspections, processing this data, and implementing deep learning-based object detection to identify the location and the number of practices on site, which would help us to automate inspection procedures. Let's talk about aerial inspections. This was our area of intent. You can see the video footage of it in this slide. It was located in US Highway 30 construction site in Tama County, Iowa. It was a 12 miles long highway construction site, and we were there during their grading activities. So we conducted automated flight missions. Our drone took off, started the mission, took hundreds of pictures by following the first rectangular grid and following the second rectangular grid, ending the mission and landing. So we processed our data by using photogrammetry applications. We stitched hundreds of images by using the photogrammetry software, and this step created a 3D model of the site. And we use this model in deep learning-based object detection. What is deep learning-based object detection? So let's talk about this a little bit. It basically takes human brain as an example and tries to create an artificial neural network that will learn information as our brain does. So it's been used in crack detection, car detection, and in many other fields. It basically classifies and localizes an object. So let's see how it happens. When I look at this picture, I'm seeing a cute dog, a coffee cup, and a building. How do I know this information? Because I'm 26 years old, I've seen hundreds of dogs, lots of coffee cups, and hundreds of buildings. So my brain automatically knows what they are at this point. So can we train a code to do the same thing? Yes, we can. So basically, we implemented the same methodology to our case, and let's talk about our results. We trained our code with hundreds of images of silt fences and rock check dams. We said this is a rock check dam and the black part is silt fence. And our validation results show that, yes, this is a rock check dam and the black part is definitely a silt fence. We trained our code with wattle images, another erosion and sediment control practice. So we said this is a wattle and our code was successful to identify it. So we basically trained our code with silt fences, rock check dams, and wattle checks. And at the end, we were successful to identify their location and number. This study improved current inspection and design procedures, managed time and resources, automated inspections, and provided better data acquisition and record keeping. In conclusion, we can say that stormwater inspections have the potential to soar to success when we use drones. Thanks for listening to my presentation.